Okay, so we're going to try and do a few examples of finding our phase constant. So to start, let's assume our phase constant is 180. So phi0 equals 180 degrees, or pi radians. Okay, where would it be on the circle? And then what would the graph look like? Okay, so on our circle, here's our circle. Here's our maximum. You can say this is A, this is negative A, and I won't do those on future drawings. And we know, well, 180 degrees is right there. Okay, so we have started not at maximum displacement, but at maximum positive amplitude, but at maximum negative amplitude. In the case of a mass on a spring, this would be maximum compression for our standard spring, horizontal spring. And so we're starting right there, and we're continuing to move forward, which means on our mass, spring's really compressed at negative A, and it's at zero speed, so velocity equals 0. It doesn't have any, at that moment, it doesn't have any velocity along the x direction, but it's accelerating that way. It's turning around to go that way. So it's about to, I'm going to put a dot, 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 and then a straight line. It's about to turn around and get moving in that direction, which we can see from this motion here, because we always keep a counterclockwise motion on our circle, that it's starting here, but it's going to start to approach our 0 line. And that's how we know it's at this negative position, getting ready to go in the forward direction. So that would be one example. How would we graph that? How would we graph that? So if we were to graph this motion, okay, here's our positive amplitude with our negative down there. This is our displacement graph. So we're starting at negative A, so we're starting down here, and we're approaching 0. We're going to go move towards 0. So down here, the only possible way I can't go further down, is towards the 0 line. So this is how my graph would look. Okay. Let's try a different example. Let's go the other direction. What if my graph with positive amplitude here, negative amplitude here, here's my time. What if my graph started something like this? Okay. So it started, let's say that's half. That's A over 2 negative. Sorry for my crunched space there, but negative A over 2. So starting halfway down in the negative position space. Okay. What would that look like? And what kind of motion's happening? So if we draw the physical graph here, okay, so if our negative amplitude is all the way to here, and the positive amplitude is all the way to here, here's our 0, we're about halfway. So here's our block. What direction is it moving based on this graph? Okay, well, I'm approaching 0, so that means on here I've got to be going to the right. Okay, I'm moving to the right. Okay, so I've got now a physical picture. It is located right here, moving to the right, because I was told on the graph it started negative A over 2 and it's approaching 0. So on our circle, where is it at on our circle? Okay, well, it's at negative A over 2. Well, negative A over 2 is right there, so that means it's either here or here. Which one is it? Which one is approaching 0? Remember, our motion is always counterclockwise, and so if it was here, this one would actually be going away from 0. 0's up here, so that wouldn't be the case. So it's got to be this one, because as it approaches 0, I get that horizontal component over there. So I know I'm right here. Now, the question of half is a little bit hard to see as an angle, but if I were to draw this right here, knowing that this distance here is 1/2, the question is cosine of phi0 is going to give me a -1/2. What angle would that be? Okay. Now the angle is actually pi thirds here, and we have 3 pi thirds here, so in this case I've got 4 pi thirds. So we're going to have, in this case this is really cramped, phi0 in this case would be 4 pi thirds. So that's how we found it. We need to know both its position and its velocity, which we can read off the graph, or we have to be told in a physical picture. And then we use the circle to kind of figure out what angle we're talking about. So in this case, we are talking about this angle right here, which is 4 pi thirds.